Good day, amazing students of Nevada. In this clip, we're going to be going over problems 1 to 5 of the Algebra 1 end of course release practice questions. All right, let's take a look at the first question. It says, which statement describes the product of m and negative 1/3 when m is a rational number? Now, before we solve this problem, let's take a look at this table right here that gives us an idea as to what result we should expect when we're carrying out operations on rational and irrational numbers. So whenever you're adding, if you add two rationals, you always end up with a rational number. A rational and an irrational number, the sum is irrational. And whenever you're adding two irrational numbers, you get an irrational answer or zero in the case where they're opposites of one another. Concerning multiplication, the product of two rational numbers is always rational. A rational times an irrational is irrational. And when you multiply two irrational numbers, you end up with rational or irrational. So you have to remember that rational numbers are numbers that can be written as a fraction. So for example, let me give you some example of a rational number. So a rational number is 1/2, either a fraction or a repeating decimal, so 0.666 repeating. Any number that cannot be expressed as a fraction or a repeating decimal, namely radical or non-terminating decimals, are known as irrational numbers. So some examples of irrational numbers are pi, the square root of 3, or 0.145, and then no discernible repetition in the patterns happen in the decimal expansion. Okay, so these are examples of irrational numbers. Okay, so in this case, m is classified as what? Let's take a look at the solution to this problem. How would you classify m? M is rational. Now, how do we know that m is rational? It's stated in the problem as indicated here that m is a rational number. We are finding the product, which is a multiplication of m, a rational number, and negative 1/3. So the question is, what kind of number is negative 1/3? Since negative 1/3 is expressed as the quotient or the division of two integers, then it is automatically rational. Okay, so negative 1/3 is rational also. All right, let's write down the reasons. The first reason is because it's stated in the problem. It's a given. And then for the second conclusion that we arrived at is because we have the quotient. Remember, the word quotient is a fancy word for division. Okay, we have the division of two integers. Anytime you have the division or the quotient of two integers, the result is always rational. Okay? All right, so what are we doing in this problem? We're finding the product of, we have to find the product of m and negative 1/3. So find the product of m and negative 1/3. So how do we express that? The product of m and 1/3 is simply m multiplied by negative 1/3. Okay. So what are we multiplying? What types of numbers are we multiplying here? We're multiplying a rational number n times another rational number, negative 1/3. So let's go back to our chart. What happens when you multiply two rational numbers? Anytime you multiply two rational numbers, your product is always rational. Okay? So let's write down our concluding statement. The product, if you multiply these two numbers, you end up with negative 1/3 m. Okay, so the product negative 1/3 m is always, okay, is, let me see how it's expressed here in the problem. Yeah, is always rational. It's always rational. What's the reason? Since the product of two rationals, basically rational times rational, is always rational. Okay? So there goes our final statement. Product of two rationals is always rational, or rational times rational is rational. Our answer is, let's look at option A. The product will always be a rational number. That is our answer. Answer number A. Okay. This test is going to be taken on the computer, so you have tools that you can use to eliminate options. Okay, so you can just cross out options as you eliminate them. In this case, option letter A was the first. The first option was the correct answer, so we didn't have to carry out any crossing up of options here. All right, let's take a look at question number 2. For question 2, it reads, Tara runs a computer repair business. The last 12 customers rank their satisfaction with her business on a scale of 1 to 10. The responses she received are given below: 1, 3, 3, 5, 5, 5, 7, 7, 7, 9, 9, and 10. Question: determine each of the 5 numeric values Tara needs to construct a box and whisker plot of her results. Complete the table below by selecting responses from the drop-down menu. Okay, so when you're doing this question, this problem, or problems like this on the test, this is going to be a response question where you have to click on the drop-down arrow to determine the correct value for your results. Okay, so I'm just going to go ahead and solve it, and I'll write in my results in these spaces provided. Okay, so first thing we're going to do is take a look at the numbers that we're provided with, and we're going to write them down in ascending order. Okay, you want the minimum first, so we're going to write them in ascending order. If you write them in descending order, then your first value will be your maximum. Okay, so we're going to start 1, 3, 3, and then we have 3 5s, 5, 5, 5, and then 3 7s, 7, 7, 7, and then 2 9s, and a 10. Okay? All right, so well, the first thing we're going to look for is the, we can look for the median first, so we can also indicate the max or the minimum. The median is known as the second quartile. All right, so the way you find the median is to find the numerical term, the numerical value that's in the center of your data set. All right, if you have an odd number of elements in your data set, then you have a number in the center. But if you have an even number of elements in your data set, you will have 2 numbers in the middle, which you have to average to get your median. Okay, so let's see how many numbers we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have an even number of elements. So what does that mean? If you have an even number of numerical values, you're going to have 2 numbers in the middle, and you have to average them to find what your median is. Okay, so if you divide 12 by 2, what do you get? You get 6. So if you have 1, 2, 3, 4, 5, 6, split it down the center, you have 1, 2, 3, 4, 5, 6. So you do not really have a number in the middle. So how do we find the median? What you do is you take these 2 middle numbers, 5 and 7, and you are going to find their average. Okay, that will be your median. Now you have 1, 2, 3, 4, 5. How many numbers do you expect to have to the right? You must have exactly the same number you have to the left. Okay, so that's how you check. 1, 2, 3, 4, 5. So that's excellent. So our median or second quartile, let's go ahead and determine what that is. Our median, which is Q2, is the average of these two numbers. How do you average? You find the sum of the numerical values divided by the number of numerical values. There are only two of them, so we're dividing by 2. Okay, that's how you find the average. So 5 plus 7 is 12. Divided by 2, you get 6. So our median in this problem is 6. So when you're using this on the computer, just click on this and then you scroll down and click on 6, and then this field gets populated with that numerical value. All right. Now we can split our numerical values into 2. So we have 6 as the median. So we now have an upper half and a lower half. Okay. So this is going to be our lower half, and that is going to be our upper half. Okay, now let's find our maximum and minimum while we're at it, since that's pretty easy to find. The first term in your ordered set of numerical values in ascending order is your minimum. So this is our minimum right there. Okay, and then the biggest number, the last set, when everything is arranged in ascending order, that's your maximum. Okay, so let's fill it in. Minimum is 1 and our maximum is 10. Now we need to find our first quartile and our third quartile. The first quartile is the median of the lower half, and the third quartile is the median of the upper half. Since these two have already been taken, we're just going to focus our energy on these 5 elements here. Okay, so what is at the middle? 1, 2, 3, 4, 5. We have 5 numerical values. That's good because we will not have to average. All right, we have a number in the center. So we have 1, 2, 1, 2. The number in the center of our lower half is 3. Okay, see 2 numbers to the left, 2 numbers to the right. So what does that tell us? It tells us that the first quartile, Q1, the median of the lower half is equal to 3. Okay, so this is right there in the center. Now let's take a look at the upper half of our data set. What's the median there going to be? The median of the upper half is our third quartile. Okay, so we have 1, 2, 3, 4, 5. So at the middle is going to be 9. Okay, let's plot that. So this is our third quartile, or the median of the upper half. If you look to the left and to the right, you have the same number of numerical values, so that's excellent. So this right here is the third quartile. Q3 is 9. This is the median of the upper half. Okay, so you can call this lower half, and this is the upper half. Okay, so let's put in those numerical values. First quartile Q1 is 3. Third quartile Q3 is 9. Okay, so there you have it. All right, let's take a look at question number 3 concerning Haley's data collection. Question 3 reads, Haley collected data from all the students in her homeroom regarding their favorite summer activity. One of the students is randomly selected from Haley's homeroom. If the randomly selected student is a male, what is the probability that his favorite summer activity is biking? Write your answer as a fraction in the response area below. So in this kind of response field, all you simply do is you click on the box and type in your numerical values, one representing the numerator and the other representing the denominator. Okay. All right, so I have this nice little formula here, table here to help you determine how to calculate probabilities when you are provided with a table. All right, so if you're given a table with 2 fields, you have your row and you have your columns, just like male and female, and then swimming, biking, and running. In this case, you have three columns. If you want to calculate the probability of um, a male doing all the activities, all you simply do is you find the sum of the males divided by the total number of all the elements in the table. So that's probability of A. Probability of female doing all the activities, you just add the total number of females you have divided by all the total number of students. But in this case, the question says, what is, if the randomly selected student is a male, what is the probability that his favorite summer activity is biking? So we are finding the probability that that a student's favorite activity is biking, given that that student is a male. Okay, that's called conditional probability. So what we're calculating in this problem is probability that we're going to have a biker, probability of having a biker or biking, given that the student is a male. Okay? So how do you calculate the probability of an outcome given a certain condition? So we have the table here. So if you look at this notation, this is probability of C given A. So all you simply do is you take the cell that's an intersection of the given condition and what you're calculating the probability of, and you divide it by the total elements in the row for the given condition. Okay, so we have probability of C given A. C and A intersect here. That's the numerator, and then you basically divide it by the total number of elements in the given condition. So it's given A, so you divide it by the total of the row containing the given condition. Okay, so you have W as a numerator divided by the row total, W plus X. Okay, now let's take a look at what we have here. We're looking for probability that the student that the student is a biker given that that student is male. Okay, so it says if the randomly selected student is a male, what is the probability that his favorite summer activity is biking? So biking and male, that is right here. That's the number of male bikers. Okay, that's going to be our numerator. So we have number of male bikers, number of male bikers. That's going to be 7. Guess what we're going to divide that by? We're going to divide that by the row total, the total number of elements in the row containing the given condition, namely male. So male is, the total number of males is what we're going to be dividing by. So we have 5 plus 7 plus 3. Okay, so number of male bikers divided by the total number of males. Okay, the total number of males is going to be 5 plus 7 plus 3. 5 plus 7 plus 3 is 15. Okay, so let's go ahead and write down our final answer here. So the probability that you have a biker, given that you're selecting from a male student, probability is equal to the total number of male bikers divided by the total number of males, which is 15. All right, so when you come up with your answer, in this question format, you are going to put your numerical values in the fields provided. So just click here, type 7, click here, type 15. That's your numerator and that's your denominator. That's your final answer. All right, let's take a look at question number 4. Now in this question, it says, which graph shows f of x equals x times the quantity x minus 2? So we have different graphs here, 4 different graphs to select which the right one is, okay? So if we're given a function in a factored state like this, completely factored, The fastest way to graph the function is by making use of the um, x-intercepts or the zeros of the function. All right, so let's indicate that graph using the x-intercepts. X-intercepts is also known as the zeros of the function. Okay, what x value causes the function to attain a value of 0. All right. Now, how do we find what the zeros are? You simply do this by solving the equation f of x equals 0. Set the function equal to 0, solve it, you will get the zeros for the x-intercepts. Okay, so we're going to take x times x minus 2, set it equal to 0. The nice thing about this format is that it is already factored for us, so we can simply use the zero product property. We set each factor equal to 0 and isolate x. X is already isolated here. To isolate x in the second equation, we simply add 2 to both sides, and that gives us our second x-intercept. Okay, so our second x-intercept is 2, and our first x-intercept is 0. So what does x-intercepts mean? The x-intercepts are the points on the graph where the curve intersects the x-axis. Okay, so that's what we're going to be focusing on. Now let's take a look at option letter A. Can you see where the x-intercepts are? First x-intercept is there because that's the first point where the graph cuts the x-axis. Second intercept is there. So for this option, our x-intercepts are 0 as the x value and 2. Guess what? This is the answer that we are looking for. Okay, now let's just take a look at the others just to practice our skill of finding intercepts. Option B, we have an intercept here and an intercept here. So our x-intercepts for option B are -2 and 0, and we see that that's not what we are looking for. How about option letter C? In option C, we have a double root situation. Okay, the x-intercept there is +2, and that is clearly wrong. Okay, remember we need 0 and +2. This has a double root of 2. And then option D, we have a double root situation again. The x-intercept is -2. That's not what we want. We need 0 and 2. So we can clearly see why the answer is option letter A. All right, let's take a look at number 5, the last in this review installment. It says the graph of f of x is shown. So we have the graph of f provided here. Now it says the function g of x is a linear function that passes through -4, 0, and 0, 2. Select all of the features that have a greater value of f of x for f of x than for g of x. All right. Now there are two things you want to note in solving a problem like this. First thing is you can use the tools provided to actually draw the graph of g. Okay, so you have a visual cue, a visual comparison of g and f of x. Second thing you want to note is that this question, as indicated here, has multiple answers that can be selected. There doesn't have to be multiple correct answers, but it's just letting you know that multiple answers can be selected as correct answers as opposed to just one. So you want to keep those 2 points in mind. Okay, so first thing we're going to do is we're going to go ahead and draw g of x. We need to see what g of x is so we can start to carry out our comparisons. Okay, all right, so there are 2 points that the line g of x goes through. -4, 0, so -4, 0, that's the first point. And 0, 2, 0, 2, that's the second point. Now, what are we going to do? We're going to draw the graph of G, okay? So let's go ahead and graph that. So all we just simply do is use our graphing tool to draw a line through the 2 points that we plotted. Okay, so you have to make sure that your lines go perfectly through the points so that your answer is not incorrect. Okay, there you have it. Now we have just sketched the graph of G. Now we're going to start carrying out our comparisons. Okay, so this is G of X, and then the black one, of course, is F of X. Now, in order to compare different things here, it's beneficial to make use of a table so that we can keep track of what we're comparing. Okay, so let's go ahead and make the table, and then we can compare the number of x-intercepts and y-intercepts and other information that we're asked to compare in this problem. All right, so we're comparing number of things that happen with G and also F. All right, so let's populate our elements. So we have number of F. So this is, let's call this F, and then this one G. Okay. All right, let's start with the first point. It says a number of x-intercepts. Let's write that down. Number of x-intercepts. Now, how many x-intercepts does F have? What on earth is an x-intercept? Those are the points that the graph intersects the x-axis. Okay, so we have 1, 2, 3, 4, 5. Okay, so we have 5 intercepts for F. How about G? Exactly 1. All right, so we have 1 for G. All right, let's move on to the next option letter B. So it says, second option, the number of y-intercepts. All right, let's put that in our table. Our next row will be number of y-intercepts. So number of y-intercepts. All right, y-intercepts are the points where the graph intersects the y-axis. So for F, we have exactly 1 at 6. So we have 1. And then G, we have exactly 1 at 2 right there. So we have 1 also. Okay, so they both have the same number of y-intercepts. But F has more x-intercepts than G. All right. Now let's move on to the next one. The value of the function when x is -5. So a nice way of writing that is, you finding the output, right? You're looking for y of -5. What is y of -5 for both functions? Okay, so all we do is we trace the x value of -5 to the graph and see what the output is. Okay, so let's go ahead and do that. All right, so for your for F, what we'll do is we go from -5. This is -5 right here. Okay, trace -5 to your graph. Okay, and then from the graph trace it out. So we see that when we trace -5 to F and trace it to the y-axis, our output is a little bit below -1. Okay, so this is an approximation here. We can call F of -5, we can call it -1.1. Okay, -1.1. Okay, how about G? When we trace the graph, the x coordinate of -5, when we trace it to G, what you notice is that you're ending up with a value that's bigger than what we had with the case of F. So you're going to trace it. It's going to be somewhere here, somewhere bigger than -1. So we can just, this is an approximation. So G of negative 5 is something like negative 0.5. Okay? All right. Now let's move on to the next one. Here we're looking at when x is equal to negative 1. So we're going to do what we did for the other option, option letter C. Option letter C, we're going to do the same with negative 1, exactly what we did, okay? So let's do, we're looking at y, the graphs evaluated when x is negative 1. So question, what is f of negative 1? What does that mean? F of negative 1 means what is the output when the input is negative 1? Okay? All right, so I'm just simply going to trace the value of negative 1 on the x-axis. I'll trace it to the graph of f and see what the output is, okay? So negative 1 is right here. We are going up, down, okay? And our output is somewhere here. So we can see it's 4.4, 4.5, something like that. So it's an approximation. Let's use 4.4. All right. Now, how about the g situation? What is g of negative 1? G of negative 1 will simply trace negative 1 vertically to the g function, to the graph of g, and then we trace that point of intersection horizontally to the y-axis for the output. And then what does the output look like here? The output is like 1.5, yeah? So something like 1.5 is our output when for g when x is negative 1. So we have 1.5. Last but not, let's see, we have more options here. It says the maximum value over the interval from 0 to 2. So from 0 to 2, we're looking for the maximum value for both functions. All right, so let's go ahead and write that down. How do we represent that? We're just going to say the maximum on that interval, that's closed interval. Okay, so we're looking for the maximum on 0 to 2. Okay, so from 0 to 2, all we are focusing our energy on is this interval right here from 0 to 2. From 0 to 2, we can see that f of x is decreasing from 6 all the way down to 3.5. G of x is increasing all the way up. All right, so what are the maximum values? The maximum value for f is actually the starting point, 6. So the maximum for f is 6. For g is increasing, so the maximum for g is actually at the end of the interval, somewhere around 2.9, or almost 3, but we can use, let me see. If I fix my graph a little bit, it looks like it's 3. Okay, yeah. So I didn't hit the point perfectly there. 2.93, so we're going to go with 3. That's much more accurate. So it's 3. All right, now last but not the least, the maximum value over the functions domain. So what's happening at the ends? That's what we're looking at. Okay, so let's go ahead and write that down. So maximum on domain. If you're taking a look at the maximum on the entire domain, what you're doing is you're going from the extreme left side, negative infinity, all the way to the extreme right side, infinity. Okay, so if you go from negative infinity to infinity, how high or how, yeah, which one, how high do they get? Okay, so it says maximum value over the entire function. Let's take a look at f first. F is heading down to the left end is going down, tending down towards negative infinity. And on the right side, it's tending down towards negative infinity also. So the right ends cannot tell us what the maximum is because they're going down. All right. Now we have to look at the interior. What is the highest point in the interior region right here? The highest point is 6. After that, it just keeps going down. comes up a little bit but doesn't retain that maximum. It goes up a little bit and then hits a lower maximum and then heads down, and the same story here too. So the maximum for the entire domain of F is 6. Now let's take a look at G. For G, on the left side, it's trending downwards towards negative infinity. On the right end, what's happening is trending upwards towards infinity. So the maximum for G is actually infinity. It goes up forever. Okay? All right, now we have our table. We're going to start carrying out our comparisons. Okay, so don't forget the question we're trying to answer. We're answering the question which one has a greater value for x. Okay, so let's take a look at the first option, option A. 5 is greater than 1. That's a check. Option B, the y-intercepts, they are the same. That's no. Option C, negative 1.1 is less than negative 0.5. That's a no. Option D, 4.4 is clearly greater than 1.5. That's good. Option E, 6 is greater than 3. That's good. Option E, which is bigger, 6 or infinity? Infinity is way bigger than 6, so that's no good. So our answers are option A, D, and E. So we just select the right options. A, these ones are wrong. D, and E. Those are our answers. Thanks so much for taking the time to watch this presentation. We know that this is a very challenging examination. So if you have any questions or like clarifications or support on any of those of the materials we covered in this presentation, or any questions on the Algebra 1 EOC, feel free to place your question in the comment section below, and we'll be glad to assist you as soon as possible. Do give us a thumbs up if you found the contents of this tutorial beneficial to you. Do not forget to subscribe so you can get the updates to the remainder of the review series in this installment. More clips can be found on mathgotserved.com under test prep and EOC. Thanks again for watching, and have a wonderful day.